Okay, so at the end of the last video, we were on question number 16. And it had told us you started with that a 14-gram sample, not that you started with it, but that a 14-gram sample had Avogadro's number of nuclei. And then it's saying you're starting with a 5-gram sample. So your MI is 5 grams. But you really want to know how many nuclei do you have in that. So if 14 grams has Avogadro's number, then you need to figure out what does 5 grams have. So take your 6.02 times 10 to the 23rd, divide it by your 14 grams, multiply it by your 5 grams, and you find out this dude has 2.15 times 10 to the 23rd nuclei. Okay? So now it says, how many nuclei will be left after 2 half-lives? And we figured out the 2 half-lives before, so we took the time they gave us, we looked up the half-life of carbon-14, and we divided, and we found out it was 2. So now you're looking for number of nuclei. So if you want, you could do NF is equal to Ni over 2 to the n. And your Ni is at 2.15 to the 23rd nuclei that you just found, and it's going to be over 2 to the 2, or divided by 4. So take your number divided by 4 and get 5.375, I think, times 10 to the 22nd, if I did that right in my head, nuclei. Okay? So they just threw you a little curve there, making you figure out the number of nuclei in the 5 grams. Alright, last question is number 17. A 1 microgram sample of radioactive material contains 6 to the 14th nuclei. After 48 hours, 0.25 of the material remains. Alright, so they give us our M initial, 1 microgram. They give us our M final, 0.25 of a microgram, so we can figure out the half-life, okay, because we know that MF is equal to MI over 2 to the n. So 2 to the n is equal to MI over MF, and that's just going to be 4. So 2 to the n equals 4, so n equals 2. And it tells us after 48 hours. So n is equal to delta t over t to the 1/2. So t to the 1/2 is equal to delta t, which is 48 hours, over n, which is 4. And so t to the 1/2 is equal to 12 hours. Right? Oh, no, sorry, 2. That's a 2, not a 4. Look at the wrong spot. So t to the 1/2 is equal to 24 hours, which is your answer to Part A. Part B then says, how could one determine the activity of the sample in 24 hours? So that goes back to the nuclei thing, because it says 6 times 10 to the 14th nuclei in that 100 microgram sample. Whoops, be good if I was on the page. And so in 24 hours, they kind of gave you the answer there, right, in Part B for Part A. In 24 hours, half of it should be gone, so it should be 3 times 10 to the 14th would be the activity. How many particles are given off, or how many particles decay in 24 hours? Half of this, because half-life is 24 hours. So it'd be 3 times 10 to the 14th. Okay, so that was all your homework questions. On the sheet that I gave you at the end of the test today, the first 4 of them have half-life questions, so you might want to try those, especially if you didn't do these, and now that I've just done them all, you might want to go to that sheet and try them. So the sheet I'm talking about is this one. Okay, so one piece of your homework for over the weekend are the first 4 of these. The next video we'll do the new stuff. that I would have normally taught you tomorrow. So, Friday, which by the time you see this will be tomorrow. And so I'll do that, and then there'll be some more homework questions with it. Okay? Thank you.